Good evening, everyone. So, in the last videos, we had a very clear discussion about stack data structure. I think I explained only the basic principles of stack, okay, and how you can able to implement the stack data structure. And these four topics are pending. I will explain these four topics in this weekend, okay. So, I'm going to move to the next data structure what we have. Okay, so the next data structure is nothing but Q data structure. Okay, the next data structure what we have here is nothing but so Q data structure. Sir, what is mean by Q data structure? How we can implement this Q data structure? We are going to discuss. Sir, already we have seen one stack data structure, right? What is the purpose of stack? You know very well. Sir, it is technically speaking, it is only one side open. Okay, means what? You can able to store the items in this direction. Means what? You can insert the objects in this direction, and in the same way, you can delete the objects from this direction, right? So insertion is possible at one end. In the same end, deletions also possible. So to represent these, we are using one special variable called top. So top will be incremented by 1 unit when you are performing insert operation. And the top will be decremented by 1 unit when you are performing delete operation. Right? This is nothing but the situation what we have seen in the stack. And initially my stack is always, my top is always representing -1, and it will be there from 0 to 2, 3, 4, something like that. When you are implementing stack by using arrays, the size of the stack is fixed. We can't add more than the elements, whatever you have fixed the size. To overcome that problem, we are implementing this stack data structure by using linked list concept. Happily, we can able to store the items by using linked list. Sir, this scenario, I think I clearly explained in the last videos, right? Now, sir, this technique is technically called as LIFO technique. Okay, this one is called as what, sir? LIFO technique means what? Last in, first out. The item which you are inserting the last will be the item you are removing first. But that is not in the case of Q. So if you take a Q, it will be represented in this style. Sir, both the sides open. Okay, both the sides open. Means what? You can add elements from one end. You are going to add the elements in this end. So this operation is called as insert operation, and we are going to delete the elements from one end. This is another side. Okay, so sir, here we have only one variable is there called top to maintain both, but here for insert operation we are using one separate variable called rare. Maybe you heard about this word. And if you are performing delete operation, in that I will maintain one more pointer called front. So I am going to maintain two pointers. One is nothing but front, another one is nothing but rare. Sir, front is always pointing from the beginning, rare is always pointing at the ending. Okay, sir, whenever an item is inserted, we will increase rare by 1 unit. Whenever an item is removed, we are going to increment front. We are not going to use decrement because two separate pointers are there. And sir, which technique it is going to follow? Sir, it is going to follow FIFO technique. Means what? The item which we are inserting first will move here, right? So this is the item which we are going to delete. Sir, general representation of Q, I think everywhere you have seen. Sir, if you are going to bank to deposit some amount, so you are going to wait in a queue, right? Okay, suppose I want to process the bank payments. So the person who sent first request, he is going to get the chance first. Like that we are going to have. So I think you have visually, sir, how this is going to be represented and how it is going to work. It is very clear for you people, right? Please confirm everyone, is the concept is clear for you people? Yes, I'm requesting every student to please respond. Is the concept is clear for you people, guys? Good, sir. Now I want to write these words, these terms in with respect to sentence. Okay. So Q is a linear. Q is a linear data structure. Q is a linear data structure which follows LIFO method. Okay. Oh, sorry, not LIFO, FIFO method. Means what? So first in, so first out technique. Okay. First in, first out method. So here the item which we are inserting, the first will be the item, so which we are removing first. Okay, the item which we are inserting the first will be the item which we are removing first. So here we will maintain two separate variables. We will maintain two separate pointers. Okay, for insert and delete operations. Okay, sir, what are those variables? So what are those variables? Front and rear. So when an item is inserted into the queue, so then front variable, sorry, rear variable, rear pointer, rear pointer will be incremented. Rear pointer will be incremented by 1 unit. Okay, by 1 unit. And when an item is removed, when an item removed from the queue, so then, so front pointer will be incremented by 1 unit. Okay, like this we have. This is nothing but what is called as queue data structure, what we have. Okay. Now, anyway, what are the common operations that we can able to perform on queue? In stack, we have seen push pop, something like that. So in queue also, the following are the various operations. The following are the various operations that we can able to perform on so queue, sir. What is the first one? Inserting an element, inserting an object into queue. What is the second one? Deleting an object from queue. So third one is what? Displaying all the elements, displaying all the objects in a queue. These are nothing but various operations that we can able to perform on queue data structure. And we can implement, okay, we can implement or these queues are divided into three types, sir. These queues are divided into three types. What is the first one? Is nothing but normal queue. So second one is nothing but a circular queue. And the third one is nothing but a dq. Like this, total how many types of queues are there? Three types of queues are there. Okay, normal queue, circular queue, and a dq. Okay, sir, we have some issues with the normal queue. To overcome that problem, we are going for circular queue, and dq is a special type of queue, sir. And you people may have a doubt, sir, we have priority queue is also there, right? Yes, that thing we will discuss as a separate unit. So heap data structure is there. Okay, there I will talk about this what you can call priority queues, sir. So in this unit, in this chapter, we are going to talk about these three data structures. Implementation will be there with arrays and linked list. Total 6 programs we are going to get. Can you please confirm, is the introduction to this queue data structure, is it clear for you people, sir? Right. So today I will talk about the normal queue implementation. Normal queue implementation by using arrays. So let us talk about normal queue implementation. So by using which method, sir? By using arrays concept we are going to discuss now. So for this I am taking one special class with name. So class NQ. NQ stands for normal queue. Sir, what are the variables that are required to manipulate with these? I need front variable, I need rear variable, and also I required size variable. And even so, I am going to represent a queue like this. Okay, one is used to represent the beginning of this queue, and another pointer is representing ending of the queue, and the size indicates how many what is the size of this particular array. I mean what is the size of maximum size of this particular array, and the queue indicates element present in that, sir. Now I am taking NQ, initializations construct, right? So I am going to write initializations. So initially your front value will become -1, and initially your rear value will become -1. And my size of this queue is nothing but assume 5 elements at maximum. And I'm creating a new integer array, okay, with elements size. So what is the size that we have given? 5. So it will create a new array with how many elements? 5 elements. Sir, okay, fine. Now I need to talk about the basic implementations. Okay, the basic methods I want to talk. What is the first method? So insert method is there, which will take a value, and this value is going to be inserted into the queue, sir. How you can able to do this? Okay, so very simple. I'm going to check array if your rear pointer is equal to size, then system dot out dot println of my normal queue, my normal queue is full. So there is no place to accommodate your object. Hence immediately it is going to return my normal queue is full, and it will stop executing that insert function. Sir, otherwise what will happen? Sir, we need to check one condition. What is that condition? Is your front and rear both are same? If both are same, then you have to assign front is equal to rear is equal to 0. Otherwise, try to take a q of rear plus plus is equal to the value which you have given. Sir, don't worry. I will take one example and I will explain how it is going to work. So consider initially, this is nothing but my normal queue, what we have with how much capacity? Sir, 5 elements. Consider this is nothing but 0th location, and this is the first location, and this is the second location. So this is the third location and the fourth location. Maximum how many elements are there? So 5. What is the size of this array, sir? 5. Sir, where is the value of a front? Where is the value of rear? Sir, my front and rear both are initially pointing to -1, sir. Okay. Both are initially pointing to -1. Like this we have. Now listen carefully. Okay. This value is nothing but -1. This value is also -1. Now, sir, I want to insert the first object as 11. How my insert function is going to work? Is your rear is equal to size? Rear is -1. Is it equal to size? No. Then is front and rear both are equal? Yes, sir. Then take front is equal to 0, rear is equal to 0. So update this value, front is equal to 0 and rear is equal to 0. Now where my rear is going to point? Okay. Sir, where my rear is going to point? My rear is pointing at 0th location. Now, q of rear, which element? Q of 0, 11 will be inserted. And since of this particular plus plus operation, this link will be gone. Now onwards, my rear is pointing to this particular position. Okay, now onwards, this particular rear is pointing to that particular position. Like this we have. Sir, everything is okay, fine. Everything is okay, fine. Now, I want to insert one more object. What is that object? So assume that object is nothing but a 22. Sir, is rare is equal to size? Rare is what? 1. Is it equal to 5? No. Then is front and rear both are same? No. Then q of rare plus plus. So first hold the object and then change this link to sir 2. Sir, this will be incremented by 2. Now assume I want to insert 33. Sir, again it will store 33, right? Then my link will be gone and rare is pointing at third location. I want to insert a 44. So this 44 will be pushed into this, and then this rare is pointing to fourth location. Now listen carefully, sir. I'm adding 55. Is your rare is equal to size? Your rare is 4. Is it equal to size? No. Then rare plus plus. First store the object and then rare plus plus. Now where my rare is pointing? 5, right? Now I want to insert 66. Now what will happen? Is my rare and size both are same? So my stack is nothing but full, and then it will return the control. Sir, where front is pointing? We have not mentioned. So here front is always pointing at 0. Sir, when this front will be active? Okay, have you observed? When we are performing insert operation, rare is very active. When you are performing delete operation, front is going to be activated. Something like a recent movie. In the first half, Chiranjeevi is going to play the major role. In the second half, Raviteja will play the major role. Okay, have you observed like that? So whenever deletion cinema came into the picture, then only this rare front pointer will work efficiently. So till that it will be ideal. Okay, sir, I think you people got clear clarity about so how this insert function in this normal queue is going to work. Can you please confirm, friends, everyone? Is it clear? Very clear with movie reference, huh? Yeah, it will be very easy for us to remember when once if you take examples, real-time examples. It will be easily injected into your mind. Hmm, correct. Sir, why no response from other students? Can you please confirm, clear up to this? Sir, why did we take front also as 0? So there is one reason is there, Vishal. See, when you are initializing, if you observe, even we are assigning rare is equal to 0. There is no use for that also, because so whenever an item is inserted, then rare is pointing to the next one step forward is there. In the same way, front is also. So even though the front is pointing at 0th location, there is not a deleted operation is performed. After deleting, your front will move to the next step. Okay, for making that empty or full, sir, I request everyone to please be on mute. Prashanti Kolli, please cross check whether you are in mute or not, because these sessions are recording. Please make sure. That's why I won't give any option for what you can call to speak. Please take a bit very special care. Only 1 hour, right? Please. Okay, we shall clear. So to work with this full operation, I mean whether queue is full or not, whether queue is empty or not, we are taking this front and then rare. So in the delete operation, you will get what is the usage of this. Okay, yeah, don't worry. In the delete, you will get clarity, right? Sir, now I want to do which operation? Delete operation. Insert is okay. Now I want to perform delete operation. So void I am taking delete. Uh, Here, sir, when we can able to delete the item? If the items are available. If item is not available means what is the condition that we can give? Sir, if your front and rear both are same, then there is no element, right? Okay, observe carefully. So I can say your normal queue is empty, and then return. Sir, otherwise what we have to do, I'm going to print system.out.println of, so your deleted object is so queue of friend. Okay, so your deleted object is queue of a friend, and we will increment friend by 1 unit. Sir, after incrementing, suppose if your friend and rear both are pointing to same reference, you have to make it as a dummy initial step. Suppose consider we have 5 elements are there. I'm keep on deleting the items. All the five items deleted. Then where should my front and rear should point? Not at the ending, because insertion will get a problem, right? Okay. So when it will say Q is full. So when rear is pointing at the end, now rear is ending only. Front also reached rear. So that means technically there is no possibility to insert the item, but logically there is a possibility, right? So that is the reason, so why this particular problem is going to come. That is the reason why we are maintaining this very clearly. Now observe carefully how it is going to work. Delete operation, have a look once. Suppose consider I have one queue is there, okay, with some 5 elements. So first element, so second element, so third element, fourth element, and then fifth element. Like this we have, and 0th location, first location, second location, so third location, fourth location. Like this we have. So my front is allocated here, right? So my rear is allocated at 5. Now how this front pointer is going to move? Observe. I want to delete first time. Sir, is front is equal to rear? No. Then deleted object is queue of front. That is nothing but 11 got deleted. Okay, right. Front plus plus. Now front will move to the first location. Okay. Is your front and rear both are same? No. So this item deleted. Now again I am pushing delete operation. Is front and rear both are same? No. Then deleted item is queue of front, which is nothing but a 22, and this link will be gone. Now my front is pointing here. One more time. Sir, is your front and rear both are same? No. Then one more time delete operation. Is front and rear both are same? No. Then deleted item is queue of front, and front will be incremented by 1 unit. Now check, is your front and rear both are same? No. Then again delete operation I'm doing just for your reference purpose. What will happen if you delete all the elements? That part I'm explaining. Is your front and rear both are same? No, sir. Then deleted object is queue of a front, this one, and then this link will be gone. Now my front is pointing to 4. Okay. Now is both are same? No, sir. Still one more item is there to delete. Is front and rear same? No. Then so it is going to delete this item, and then now your front is pointing to 5. Now observe carefully. Sir, after incrementing, your front and rear both are pointing to same. If it is the same, reset this value to -1. Okay, reset this value to -1. Front is -1 and rear is also -1. So that we can insert a few more objects here. So, but in this possibility, is there any possible to add the items? No. If you are trying to add, even I have vacant positions, where rear pointing 5. What is the rear value? 5. What is the size value? 5. Both are same, right? So it will display Q is full. But there is a possibility, right? So to overcome that problem, after deleting every time we will check. So and then we will make it as a front. Okay. So this is nothing but how you can able to perform delete operation. Clear, friends? Everyone, please confirm. Vishal, I think you got very clear clarity about this now, right? Right, sir. Now, so what is the next one? What is the next operation that we have? Last operation, we have to display the objects, right? So void display object I am taking. Sir, when we can't display, if your front is double equal to rear, we can say, so my my normal queue is empty. We can't able to hold the objects. We can't able to store. Sir, otherwise, for integer I is equal to 0, sorry, not I is equal to 0. I is equal to front, I less than rear, I plus plus. So we are printing. I am not using new line, system dot out dot print of. So q of I, okay, q of I plus followed by some space. After this, system dot out dot println. Like this, we are going to get. No, Vishal, we should not use less than or equal to, because you know very well. So wherever the object is inserted, after that rear is moving towards next step. That means one step. Yes, correct. One step forward rear is there, right? And one step forward front is there. If front is pointing at 0th location, that doesn't mean that 0th location got deleted. Okay. If your rear is pointing at 4th location, that doesn't mean that in 4th location element is there. So when you insert, it will store the value and then it will move to the next, because initially it is there at -1. So that means it is not in bounds. So after performing increment, it will move one step forward, even for deleting also. Then only we can make it as a beginning. Okay. Now, sir, that's all about the display. I think no need to explain. Now let me run the code, sir. Sir, I am taking normal q. Q is equal to, so new normal q. So I need to display at very beginning, sir, q dot display. Can you please display the items? Sir, what output we are going to get? Sorry, here we don't have any elements in the queue. So immediately it is going to rise. Sorry, immediately it is going to tell my queue is empty. Yes. Now I want to perform insert operation. So q dot insert of, I am taking 111. Like this, I want to insert. Let us check now. Is 111 got added or not? Yes. Now I want to take 222. I want to take 333. I want to take 444. So I want to take 555. Like this, I want to store. Now see what will happen. Sir, is it possible to add 666? No. If you are trying to store, what will happen? Immediately it is going to raise error message saying, boss, my normal queue is full. I can't accommodate. Now, sir, let us perform q dot delete. Sir, which operation, which element it is going to remove? That is very, very important. So the item which we inserted first, that is nothing but 111 will be removed. Sir, after that, can you please display the functions? So I am taking q dot display. After this, I am going to display the objects. Now, what will be the output? You can see, is that object removed or not? Yes. Like this, we can perform delete operation. So I think you people got very clear clarity about this normal queue implementation by using arrays concept. Please confirm any doubts in this program, sir. Clear? For delete, we can pass value as a parameter. No, Swapnil, we should not pass, because delete operation will always return first element, because it is going to follow FIFO technique, right? Inside a queue, if any person is there with name Swapnil, if I ask Swapnil, come first, I will give cash for you. So what happens for the remaining people who are there in front of you? They will get a fight with you, right? That is the reason why we are moving for queue. I think you got the clarity. Right, sir. Sir, with this, I am closing the session today. Tomorrow we will meet for the continuation. I will talk about the linked list implementation of this queue. Okay. Right, sir. I have some small emergency work is there. That's why I'm closing 10 minutes before. Okay. Tomorrow we will see, sir. Yeah, yeah. I will upload the notes after half an hour. Okay. Maybe you can expect at 9 o'clock. Thank you.